Welcome back to the video series on procedural audio in Unity and Unreal Engine. This is a brief introduction as to why I chose JUCE native plugins for developing procedural audio in Unity while we wait for DSP graphs in .audio. In this video, we will look at the various alternative strategies for procedural audio in Unity, look at the native plugins and the benefit of using JUCE to write these plugins, what the challenges are, and some resources I've found useful. This is the last Death by PowerPoint session, or Death by Keynote in this case as I'm using a Mac. The next video we will start programming, so Death by Xcode. I will make a video later showing the differences when using Visual Studio on Windows, but the JUCE software makes this fairly seamless. What alternatives are available? I've briefly trialled middleware like Fmod and WWise, and I'm aware you can incorporate procedural audio, but it's just too expensive for my projects and I prefer implementing in the game engine itself. libpd integration incorporates pure data into Unity projects, which works well and is still actively developed, but unfortunately there's no support for Android target platforms. This was my start point a few years ago, but now I prefer to write my own code using a fully supported commercial framework. Although it's possible to write Unity procedural audio as a C# script, issues such as memory management and data management in C# make it difficult to write performant code, even though the final code built for the platform is C++. Also, you would need to write all of your own DSP code, which is difficult to get right. Unity DSP graphs will address a lot of this in the future, where they've developed high-performance C#, but this is still experimental, with no recent development and no launch date announced. My preferred route currently is to develop my own native audio plugins, and although Unity have an SDK, my preference is to use JUCE as it provides a solid audio development platform with sophisticated DSP code and a pre-built Unity interface. Unity native plugins allow C or C++ code libraries to be incorporated into Unity projects. First, you code the audio plugin as a dynamic library based on the platform of the editor. Then you need a C# script glue for the game scripts to be able to access these plugins. These are loaded as assets into the Unity project and become visible on the Unity audio mixer. The big advantage of JUCE is that you just need to write a standard JUCE plugin and select Unity as a build platform. This will build all of the necessary library code and C# glue script, which can then be simply dropped into the Unity project. Those of you who are familiar with Unity might have noticed a slight problem here. Although the plugin is on the mixer, it is not an audio source that can be attached to an object in the game, so can't be spatialized. Later, we will create a small additional plugin that will route the mixer channel output to an audio source, and a small script that will allow the audio to be fully spatialized. There are challenges in this approach. There is a lot to learn. JUCE takes time to get into. There are third-party video tutorials and written tutorials on the JUCE website, but JUCE is a huge framework, and there are always different ways to implement solutions. I'll show you the way that I've found best for procedural effects. This differs from what you see in other tutorials, as they are generally geared towards media players, DAW audio plugins, and MIDI synthesizers. Also, don't give up with JUCE. I've had to run through the tutorials many times to really get to grips with it and learn about some of the more advanced features of C++. But now I use JUCE extensively, not only for sound design, but also for developing bespoke applications and analysis tools. There are some golden rules of DSP programming, and I'll cover those as we start coding. Next, the plugin is for each editor platform, not deployment platform. So one plugin should work for deployment on iOS, Android, Windows or Mac. You may need specific code in the plugin for mobile platforms, but JUCE will be able to handle this. WebGL platform will not work. Unity has no way of accessing the audio buffers directly, and on audio filter read won't work. I promised some resources and I've included the links below. First, the JUCE website, which has an extensive set of tutorials and documentation for the framework. You can also download JUCE here or clone it from GitHub. Also, there is an active forum to discuss problems and issues. There are a couple of places on YouTube to find JUCE-specific tutorials. TheAudioProgrammer has an extensive set of JUCE tutorials focused on building synth plugins, which are useful for procedural audio. MatKat on the Free Code Camp channel focuses on plugin effects. At the start of the videos, he shows how to set up JUCE for Xcode and Visual Studio, as well as configuring GitHub for your projects. If you want to learn more about C++, particularly performance and some more advanced features, I'd recommend TheCherno. He's a games programmer, so no audio focus, but the issues he covers are the same. There are good videos on templates, smart pointers, memory allocation and loads more. All are really well explained in short 15-minute videos. Finally, I have a link to the Unity Native plugin SDK. This is the documentation for the code I linked in the last video and is definitely worth reading as it has a chunk of interesting audio programming ideas. In the next video, we will create our first Unity plugin with JUCE and get it working in a blank Unity project. Hope to see you next time.